Hi everyone, welcome to our session, Getting Started with Amazon Web Services. My name is Mhlongo. I am a Senior Solutions Architect at AWS. Let's have a look at our agenda for today. Our agenda, we are going to talk about introduction to AWS, AWS Global Infrastructure, foundational services, and lastly, we are going to demonstrate a demo on how to deploy a scalable web application using EC2 auto-scaling with multiple instance types and purchase options. Okay, what is Amazon Web Services? AWS provides on-demand delivery of technology services through the internet with pay-as-you-go pricing. This is known as cloud computing. The AWS Cloud Platform encompasses a broad and deep set of services that includes compute, storage, databases, analytics, networking, mobile, developer tools, management tools, IoT, security, and enterprise applications that helps customers build sophisticated, scalable, and secure applications. Capacity can grow and shrink instantly, and businesses only pay for what they use. Amazon is a unique company in how we operate. Everything we do starts with our customers, and we work backwards from there. 90 to 95% of our roadmap is driven by customers' feedback. Let's have a look as to what are the advantages of moving to the cloud. The first is agility. Organizations around the world are moving to a cloud-based infrastructure to increase IT agility, as the cloud gives you easy access to a broad range of technologies so that you can build nearly anything that you can imagine. The second is cost savings. The cloud allows you to trade capital expenses such as data centers and physical servers for variable expenses, and you only pay for IT as you consume it. The third one is elasticity. With cloud computing, you do not have to over-provision resources upfront to handle peak levels of business activity in the future. And the fourth one is that moving to the cloud allows customers to innovate faster because they can focus their highly valuable IT resources on developing applications that differentiate their business and transform customer experiences instead of the undifferentiated heavy lifting of managing infrastructure and data center. Lastly, with the cloud, you can expand to new geographic regions and deploy globally in minutes. Let's have a look at as to what sets AWS apart. I am not going to linger too long on this slide. Some of the points I want to highlight is that security is our number one priority, and we provide customers with fine-grained controls to secure their workloads. Pace of innovation. We have more than 200 plus services to support any cloud workload. Our experience. We have unmatched experience. We've been building and managing cloud since 2006, and today we have 1 million plus monthly active customers. Machine learning capabilities. More machine learning happens on AWS than anywhere else. Our ecosystem. We have 100,000 plus Amazon partner network. Lastly, we are an enterprise leader in cloud infrastructure as a service. AWS has the broadest and deepest functionality with over 200 services. And again, we are continually expanding our offerings to support any cloud workload. Customers can choose what is right for them and use as much or as little AWS products as needed. Everything is built on core services such as compute, storage, databases, and networking. Customers can leverage higher level services to remove undifferentiated heavy lifting or continue to operate with core, primitive services to function as they have in the past. Higher level product categories range from analytics, such as data warehousing, to enterprise applications such as visual desktops and application streaming. We offer a robust set of resources to help in the journey, such as professional services and support. Lastly, AWS Marketplace gives access to thousands of commercial and open source solutions that customers are familiar with and already running in their existing environments. The AWS cloud has been architected to be one of the most flexible and secure cloud environment available. AWS Scale allows significantly more investment in security policing and countermeasures than almost any large company can afford themselves. With the shared responsibility model, AWS takes care of security of the cloud. This is the physical infrastructure, the facilities, the actual compute, and building blocks. And from shared security responsible model, you as a customer, you take care of the security in the cloud. This means you secure workloads and applications that you deploy onto the cloud. This means that you have the flexibility to put more emphasis on security of sensitive data. AWS supports more security standards and compliance certifications than any other offering, including SOC 1, SOC 2, SOC 3, ISO 27001, PCI DSS, HIPAA, FedRAMP, FIPS 140-2, and many more, helping customers satisfy compliance requirements for virtually every regulatory agency around the world. We have 98 plus security standards and compliance certification, and you can visit our compliance section in our website for the full list. Let's have a look at AWS Global Infrastructure. The AWS cloud spans 87 availability zones within 27 geographic regions around the world. We've announced plans for 21 more availability zones and 7 more AWS regions in Australia, Canada, India, Israel, New Zealand, Spain, and Switzerland. A region is a physical location in the world where we have multiple availability zones. Availability zones, or AZs, consist of one or more discrete data centers, each with redundant power, networking, and connectivity, housed in separate facilities to substantially reduce the chance of simultaneous failure. With Amazon CloudFront, AWS operates the largest global content delivery network to enable customers to securely deliver content such as videos, applications, images, and APIs to their end users with low latency and high transfer speeds. Amazon Cloud uses a global network of 410 points of presence, 400 plus edge locations, and 13 regional edge caches across 90 plus cities in 47 countries. Let's have a look at an overview of AWS foundational services. As discussed in the previous slides, AWS offers a broad set of cloud-based products that you can use in combinations tailored to your organizational needs. To access the services, you can use the AWS Management Console, the command line interface, or software development kits. Let's have a look at networking on AWS. Amazon Virtual Private Cloud, Amazon VPC, enables you to launch AWS resources into a virtual network that you've defined. This network closely resembles a traditional network that you'd operate in your own data center, with the benefits of using the scalable infrastructure of AWS. After you create a VPC, you can add network-related configurations and features such as subnets, IP addressing, routing tables, gateway and endpoints, traffic monitoring, VPN connections, etc., etc. Let's have a look at compute on AWS. Compute is a core to every customer's infrastructure, and customers consume compute in lots of different ways. Amazon EC2 offers the broadest and deepest compute platform, with over 500 instances and choice of the latest processor, storage, networking, operating system, and purchase model to help you best match the needs of your workload. Customers have lots of options for containerized workloads. They can choose from Amazon Elastic Compute Service, ECS, which is a managed container orchestration service that makes it easy for you to deploy, manage, and scale containerized applications. They can also choose to use Amazon EKS, Elastic Kubernetes Service, which is a managed container service to run and scale Kubernetes applications. Or they can use AWS Fargate, a serverless compute engine that lets you focus on building applications without managing servers. AWS Fargate is compatible with ECS and EKS. Lastly, customers can use AWS Lambda, a serverless, event-driven compute service that lets you run code for virtually any type of application or back-end service without provisioning or managing servers. You can trigger Lambda from over 200 AWS services and software as a service applications and only pay for what you use. Let's look at storage on AWS. AWS delivers broader storage portfolio in the industry from object, file, and block storage to backup and data transfer services. Amazon Simple Storage Service, Amazon S3, is an object storage service offering industry-leading scalability, data availability, security, and performance. Customers can store and protect any amount of data for virtually any use case, such as data lakes, cloud-native applications, and mobile apps. S3 provides cost-effective storage classes and easy-to-use management features. We also have Amazon Elastic Block Store, EBS, which is an easy-to-use, high-performance block storage service for use with EC2 instances. And we have Amazon Elastic File System, EFS, which is a serverless, set and forget elastic file system. It automatically grows and shrinks as you add and remove files with no need for management or provisioning. It enables you to create and configure file systems simply and quickly for AWS Compute Services. Let's have a look at databases on AWS. AWS provides customers with fully managed, purpose-built databases to modernize their data infrastructure. Today, we'll only have a look at RDS, DynamoDB, and Redshift. Amazon Relational Database Service, RDS, is a collection of managed services that makes it simple to set up, operate, and scale databases in the cloud. Choose from 7 popular engines: Amazon Aurora with MySQL compatibility, Amazon Aurora with PostgreSQL compatibility, MySQL, MariaDB, PostgreSQL, Oracle, and SQL Server. We also have Amazon DynamoDB, which is a fully managed serverless key-value NoSQL database designed to run high-performance applications at any scale. DynamoDB offers built-in security, continuous backups, automated multi-region replication, in-memory caching, and data export tools. And let's have a look at Amazon Redshift, which is the fastest and mostly widely used cloud data warehousing. Amazon Redshift uses SQL to analyze structured and semi-structured data across data warehouses, operational databases, and data lakes using AWS designed hardware and machine learning to deliver the best price performance at any scale. Let's have a look on how you can get started with AWS. You can start with AWS free tier, which provides free hands-on experience with the AWS platform, products, and services. You can have a look at our AWS solutions, which are technical reference implementations built and vetted by AWS architects and AWS partners, designed to help customers solve the common problems faced by their peers around the world. Also, we offer both digital and classroom training. Free digital training allows you to learn online at your own pace. With classroom training, you can learn best practices from an expert instructor. AWS training and certification can help you be more effective and do more in the cloud. Now, we are going to start our demo where I will demonstrate to you how to deploy a scalable web application using EC2 autoscaling with multiple instance types and purchase options. Okay, thanks everyone for joining me in this demo. I will show you how to deploy a scalable web application using EC2 autoscaling with multiple instance types and purchase options. For our instance type for this demo, we are going to use on-demand instances as well as EC2 Spot instances. So Amazon EC2 Spot instances let you take advantage of unused EC2 capacity in the AWS cloud. Spot instances are available at up to a 90% discount compared to on-demand prices. You can use Spot instances for various stateless, fault-tolerant, or flexible applications. In this demo, we are going to assume that our web application, it is stateless and fault tolerant and can run on on-demand instances as well as EC2 spot instances. Let's have a look at our architecture. So we are going to deploy an AWS Cloud Formation Stack, which will include an Amazon Visual Private Cloud with subnets into availability zones, an AWS Cloud 9 environment. This is the IDE, Integrated Development Environment, that we are going to use to run our commands. And it will include supporting IAM policies and roles, supporting security groups. We are going to deploy an Amazon EC2 launch template, an application load balancer with a listener and target group, an Amazon EC2 auto-scaling group with a scheduled scaling policy and a dynamic scaling policy. And lastly, we are going to use AWS System Manager run command to emulate load on the service. A quick high-level architecture of our solutions. As I've already mentioned, we have a VPC. Inside our VPC, we have Cloud9 IDE, we have two availability zones, and we have public subnet, we have on-demand instances, spot instances, we have an auto-scaling group that will be used to scale our EC2 instances, and we have elastic load balancer that will balance our incoming traffic to our EC2 instances. So let's go ahead and deploy our CloudFormation template. So you go to an AWS console, you go to CloudFormation, and we can create our stack from here. So we are going to upload our template, which has the configuration details. It's a YAML template. Stack name, we are going to call it my EC2 workshop. We are going to leave the IP addresses as default. We are going to use this to leave these options as default. You can do different configuration as required. We are going to click acknowledge. So this is an acknowledgement that the cloud formation template will create IAM resources. Okay, now our creation progress has been initiated. It may take up to 5 minutes for our CloudFormation template to complete the creation of the resources. It's creating the resources that I've already mentioned. If we want, we can quickly have a look at our CloudFormation template. So this is the template that we are busy deploying in our AWS environment. So basically, what it does, CloudFormation, it allows you to automate the deployment of resources into AWS Cloud. And once it's busy creating, we can come to resources to have a look of what is being created. So if you have a look here, it's creating a VPC, it's creating a security load balancer, an internet gateway. We have instance profile. So this is it's attaching a gateway. So this is what is being currently created. And if you come to events, you will have a look. You can see all the events that are being currently happening with the creation of the resources. And you can refresh if you want to see the progress of the creation. So we are going to give it a moment. And one thing to note is that it's also creating a Cloud9 IDE environment. So as an additional component that we need for our demo. So we'll let it run. Let's see how it's that progressing. Okay, so it's currently being created. And once it's done, what we're going to do, we're going to go to our Cloud9 environment and we're gonna start configuring the environment. So the Cloud9 environment is the environment that we are going to use for configuration, for configuring our workshop. Okay, so this one is completed. Okay, completed. So our template, it's been deployed, and if you come to the outputs here, you can see quickly the information that has been created. So your VPC public subnet, instance profile, and so forth as mentioned. So let's go to Cloud9. Okay, so this is the environment that we have created now. So what we are going to do, so Cloud9 allow us to run the configuration commands for our demo. And what we are going to do is to quickly uninstall the older version of AWS CLI command line interface. I will quickly close this. I will make this a little bit bigger. Okay, so that what we are doing is uninstalling the older version of CLI. I just want to make sure that we are running the latest version. That might take a couple of seconds. Okay, that is done. Now we are busy installing the latest version. So we'll let it run. It shouldn't take long. So, okay, that is done. So what we are going to do, we can just confirm our version. So as you can see, we have CLI 2.7. So that's the version we want to work on. So now we are going to install the dependencies for use in the demo. If you see here, currently there is nothing. We will populate the directory with all the information that we need. Okay, that is done. So we are going to clone the GitHub repo. So for us, in order to execute the steps in this demo, we need the demo GitHub repo. Okay, we are busy cloning that. So next, once it's done, completed, we are going to change to our directory now that we are going to be working on, which is the EC2 Spot workshop directory. Okay, that is done. So firstly, we are going to configure the stack name environment variable with the name of our CloudFormation 9 template. So if you remember, we gave our CloudFormation stack name my EC2 workshop. So to do that, we're going to run the following command, and we have exported our stack. Now we are going to load the CloudFormation stack outputs on environment variables. Okay, that has been completed. So the next step is to create an EC2 launch template. So an EC2 launch template specifies EC2 instance configuration information. So the ID of the Amazon machine image, the instance type, a key pair, security group, and other parameters that we are going to use to launch our EC2 instances. So we can firstly have a look at our current launch template to see what information or configuration information we have here. So we'll expand our directory, we come here and launch template. Okay. So if we examine our current launch template, you see there the instance profile, there's no IRN there, the Amazon machine ID, it's not there, the security group. So we need to make sure that that information is available. So we're going to update our template. Okay, so this should update our template. Here we can use the latest machine image. So depending on which region you want to run your launch template, you will have to make sure you're using the latest Amazon machine image. So now that we have done that, the next step will be we need to create the launch template from the launch template config file that we have just updated. Okay, so that is done. If you have a look here, you can see our launch template ID, our template name, and the time and date that it has been created. So what we can do now is we can go to our launch template console to quickly have a look at our template. Oh, sorry, I've closed the environment. Okay, we are back to our environment. Let's go to the template console. Okay, so this is our launch template that we have just created. So now, moving to the next, so at the bottom here is the launch template details. Can make this a bit bigger so it will show you the machine image and the security group. And we can verify the contents of this launch template. Okay, so having a look here, you can see the contents of our launch template and the user data script configured on the launch template. Now that our launch template is ready, we are going to deploy the AWS Elastic Load Balancer. So the load balancer, it will be used to distribute incoming traffic to our application across the EC2 instances. We can first examine the configuration file of our application load balancer. Okay, so this is the current details or configuration of our application load balancer. There are values here that have placeholders such as public subnet 1 and 2 and load balancer security group. So we need to populate the configuration file with the outputs of our CloudFormation stack. Okay, after we have done that, we need to create our load balancer. Okay, so our load balancer has been created. As you can see, the load balancer subnet, the zone name, availability zone name, and all the current state is busy provisioning and it's internet facing, so, and the DNS name as well. So as an on the upcoming step, we need the load balancer ARN. Okay, that's our load balancer ARN. Now we can go to the load balancer console to see what is being created. Okay, if you come have a look here, you will see our load balancer, the name, and it's busy provisioning. So this is our load balancer details. If you scroll down here, the host zone name, the creation time, the availability zones, the security groups that it's using. So we will proceed. So now we are going to have a look at our target group and update the details of our target group for our load balancer. So we will come here, look at our target group, which is used by the load balancer. So if you have a look here, you can see the VPC ID is not updated. So we need to update that details. Okay, I will quickly do the update by running the following command. Okay, that has been updated. So now we are going to create the target group. This is the target group for our load balancer. Okay, so if you have a look here, you can see our target group has been created with the help, it's listening at protocol HTTP port 80, the VPC ID, health check is enabled, interval for the health check is 30 seconds and so forth. So that has been successfully created. Now we will need the target group ARN of the target group that we have just created for the upcoming step of our demo. So we are going to export it. Okay, that is done. So we need to modify our target group JSON. We can firstly have a look at the current configuration. So we need to update the value of target group ARN with the ARN. So if you can see here, the value, there is no ARN there. So we need to update that. Okay. We have updated that. Now we need to modify the target group to set the deregistration delay timer to 2 minutes. So this is to match the spot interruption notification time because the default one is 5 minutes. Okay, so we are going to do that now. Okay, that is done. Now we can go to our target group console to have a look at our newly created target group. Okay, so here's our target group on port 80, protocol is HTTP. So that has been created. Now we are going back to our IDE. So we need to move to the listener, right, of our load balancer and make the update. So again, you will notice we have values here, the load balancer ARN and the target group ARN. We need to make the updates for those. Okay, now our load balancer ARN and our target group ARN has been updated. Now we need to create the listener. Okay. Okay, so our listener has been created. What we can do, we can go back, we can go to our load balancer to check our listener details. Let's have a look. Okay, so we have one listener that has been created. Okay, so let's refresh here. Okay, now it's active. So our load balancer is ready. So as a next step now, we are going to create an EC2 auto-scaling group. So this is to launch, maintain, and scale EC2 instance dynamically for our application. We are going to create this EC2 auto-scaling group. This is to help us meet our cost optimization goals. So EC2 auto-scaling allows us to combine purchase option and instance types with our auto-scaling group. So stateless web applications are a great fit to run on EC2 spot instances, like I've mentioned previously, as they can tolerate interruptions and are often flexible to run on multiple instance types. So to do that, we are going to go back to our environment, our IDE, and we are going to have a look at the current configuration of our EC2, of our auto-scaling group. So having a look here, let me just make this a little bit smaller. So for the purpose of the work of this demo, let's assume that our workload is flexible to run on any of the EC2 types, matching the following configuration as we can see here on our configuration file. So we have memory there, it's minimum 4. Let's start with the CPU. So we have minimum 2 of CPU, max is 2 CPU, memory is minimum is 4 gig, and maximum is 16 gig. Instance with CPU architectures for Intel and AMD, and there is no GPU instance for this demo. And this instance belongs to the current generation. So we are excluding enhanced instance families in this auto-scaling group. So going down to see more configuration, if you have a look at on-demand allocation strategy, we have selected lowest price. So this makes auto-scaling to trial to launch on-demand instances from the lowest priced instance pools. And we have on-demand base capacity set to 2. So this means the first 2 EC2 instances launched by EC2 auto-scaling will be on-demand instances. Then we have on-demand percentage above base capacity set to 0. So all the additional instances will be launched as spot instances. And lastly, our configuration here is that the spot allocation strategy is capacity optimized. So what does this mean? It means it will instruct auto-scaling to pick the optimal instance type on each availability zone based on the launch time availability of spare capacity for our instance type selection. So we need to update our ARN for our auto-scaling group, target group ARN with the subnet as well. So to do that, we are going to run the following command. Okay, that it's been updated. Now we need to save and configure our auto scaling group. Okay. Okay, so that is done successfully. Now we can go to our auto scaling console to check the newly created auto scaling group. So this is our auto scaling group. So as you can see, the configuration. So now we have deployed an EC2 auto scaling group with mixed instance type and purchase option. So if we have a look here, the desired capacity is 4, minimum capacity is set to 2, and maximum capacity is 12. So that's our configuration for the auto scaling group. So now we need to go to our load balancer, DNS, and see our website. So we're gonna need the name, the DNS name for our load balancer for that. So this is the DNS name. We're going to copy that and we'll open a new tab and test our application. Okay, so it has been successfully deployed, as you can see here, and currently it's using my instance type C6A large. If you refresh, you can see it's changing to type instance C5 large. And we refresh and it changes across the different instances. So basically our application has been successfully deployed and it has been deployed across these instance types. So now what we are going to do, right? We are going to use dynamic scaling in our auto scaling group. So this is to automatically scale out and scale in as our application load fluctuates. So when you configure dynamic scaling, you must define how to scale in response to changing demand. So let's take for an example, right? So if you have a web application that currently runs on 2 instances and you do not want the CPU utilization of the auto scaling group to exceed 70%, you can configure your auto scaling group to scale automatically to meet these demands. So the policy type determines how the scaling action is performed. So now we are going back to our Cloud9 environment and we can have a look at our auto scaling group automatic scaling policy, right? So this is our current auto scaling group automatic scaling policy. So everything looks fine here. So we are going to apply the scaling policy to our auto scaling group. Okay, so that has been done. So we can go to our auto scaling console and check our newly created scaling policy in the scaling policies. Okay, so if you have a look here on our dynamic scaling policies, you can see the policy type is targeted tracking scaling, enabled, yes, and execute policy when as required to maintain average CPU utilization of 50. And what to do, the action is add or remove capacity units as required. And the instance need 180 seconds to warm up before including the metric. And it's currently enabled. So our policy for dynamic scaling is currently enabled. So the next step, we are going to stress the app with AWS System Manager. So AWS System Manager provides you a safe, secure remote management of your instances at scale without logging onto your servers. So replacing the need for base station host, SSH, or remote PowerShell. And it also provides a simple way of automating common administrative tasks across groups of instances, such as your registry edits, user management, and software and patch installation. So now we will emulate CPU stress on the instances in our automatic scaling group by issuing a remote command to each instances. So we can go back to our IDE and have a look at our system manager configuration file. Okay, so this is the current configuration of our system manager. And now we are going to stress it. Okay, so we have issued that command, and what we can do now, we can go to our system manager to monitor the status of our run command. Okay, we just have to make sure we are on the right region, which is Ireland. Okay, so our remote command has been executed successfully. As you can see here, it is in progress. It might take a few minutes to start stress, to start emulating the CPU stress on our EC2 instances. In the meantime, we can also go to CloudWatch console to monitor the status of our alarms. So CloudWatch is the monitoring tool for our environment. Okay, so if you have a look here, the status of our alarms configured by the target tracking policy, you can see the first one here, CPU utilization is greater than 50 for 3 data points within 3 minutes. So it has been, the alarms have been triggered. And we can also go to our auto scaling console and watch the activity history. Okay. So if you come and have a look at the activity history here, you can see that there has been events happening. So a user request creating an auto scaling group, changing the desired capacity from 0 to 4, right? An instance was started in response to a difference between the desired and actual capacity. So now we are increasing the capacity from 0 to 4. So this is the activity history, so which means our dynamic auto scaling is taking place. So if we go to our EC2, let's see, so this is, it's busy running. Our alarms are busy running as well. So you can see CPU utilization 50. And what is happening now is the creation of the EC2 instances. So if we come to our EC2, let's come to our EC2 and now let's check our instances. Right? So if you have a look here, these instances have been deployed. Let's do this. So they are currently being deployed as to meet the demands of our capacity. So basically, this is how auto scaling works, right? And it's running successfully. We're having our instance being created, as you can see here, my EC2 workshop. So these are the different instances. It will continue to launch more instances. So you have, as you can see here, C5 large, C6 large, C5 large as well. So as the stress test is continue to run here, it will be loading different EC2 instances. So that's how you actually create a highly available and scalable web application using different instance types and purchase option. I hope that was very informative. So again, our website here, it's still up and running. So there is no impact. Even if we are doing a stress test, there is no impact to our website. It is still up and running. Just want to have a look. As you can see, as now we are having more EC2 instances, right, being initialized. So what does this mean? Our auto-scaling police, as we stress test the CPU and as the instance reach the maximum CPU that we specify, what it's doing, it's launching additional EC2 instances to keep up with the growing demand for the capacity. So this will keep growing as long as I keep stressing up my CPU. So this shows you really how to deploy a highly available and scalable web application. I hope you found it very informative, and thank you for watching.